Good morning. Welcome to this Other People's Code talk track. I'm speaker number 2. We just heard from Filippo talking about the challenges of taking code from elsewhere via software dependencies and trying to run them internally, and how to be able to do a risk assessment on that. But maybe you don't use software dependencies. I don't know. We're going to switch tracks a little bit. Instead of talking about software dependencies, we're going to talk about vendor dependencies. Who am I? I don't usually do speaker background slides, but I think it's kind of important to explain a bit of the angle that I am approaching with this presentation. So I've been at Square, as you've heard, around 5 years, all within the InfoSec org. I'm on the privacy engineering team. My day-to-day is generally working on engineering projects and tasks revolving data flow and data access. I've also spent 4 of those years participating as part of a vendor security committee or program, reviewing requests that come in for potential vendors just via a security standpoint. People often ask me why I'm interested in vendor security. Some people call it boring security. And my answer is that since I come from an academic background, this whole forms and paperwork and process piece of InfoSec is very interesting to me. And the second reason is I think looking at vendor security more deeply really ties into my aim and my goal of trying to understand how data flows in and out of a company's infrastructure. You can also follow me on Twitter. You feel free to take pictures of slides and tweet at me. My Twitter handle should be at the bottom of every slide. I do plan to leave a few minutes for Q&A, but for those of you who hate microphones or otherwise prefer a more asynchronous form of communication, this is the alternative. Okay, vendors. Let's talk about vendors. If any of you have tried making a Google search about third-party vendors and should we worry about them or not, you'll start seeing results like this. Basically stresses to folks that maybe you should be really trying to keep an eye on them, whatever that means, or somehow be able to figure out a way to manage that risk. Why is that? I'm going to tell you a story. This is a story of the perspective of an engineer just trying to do their job and ending up in the thorny edges of security despite all good intentions. This is Bob. Hi, Bob. One day, Bob receives an alert ticket from the local security team because it turns out the automated security system detected unauthorized access from a service that he owns connecting to the internet. Thankfully, there were systems to deny this automatically. But Bob is looking closer and realizing that this, in fact, might be a valid domain to talk to the outside world. Why is that? He says, well, it says company-cdn.com, and I work at company.com, so probably we use company-cdn.com, so maybe this is okay. Maybe there was a change that was not properly communicated. So Bob goes to chat with his coworker, Alice, about this. Bob says, hey, Node-C. Alice is like, what? We don't use Node-C, we use Node-F. Bob makes the decision to whitelist Node-C anyway because, it probably belongs to their company. It's probably a company asset. What harm could there be? So he's like, sure, allow it. Oh no, Bob. So what happened next? Let's fast forward a few days. Here's a very heavily edited conversation from the engineering team a few days later. The TLDR is that upon prompting from a customer, they discovered that there was some anomalous behavior occurring in the team's services that were causing changes to customer accounts, and despite the auditing systems in place, they couldn't figure out why these actions were happening. The logs would say half the story. There were clearly some other things happening behind the scenes, but they just were like, something weird is going on. Thankfully, they discovered it was due to a red team attack. But let's walk through the post-mortem as to the timeline of events of what happened here. So I've got split here, red team, blue team. So what happened is the red team tried to do some kind of domain fronting event, domain fronting attempt. That triggered the access alert that Bob received. Bob's like, yeah, whatever, I'll whitelist it anyway. And then so when the attacker tries to do the domain fronting attack again, they succeed. So then they're able to download some external tools, because at this point, they can download whatever they want from the internet. They're able to conduct their targeted attack, which is that conversation you saw a few days later. Because this is a red team exercise, they're like, it's kind of weird that nobody has noticed anything before, so let's call support and really try and light some fire under these engineers. So they call support. The Eng team starts investigating, the Eng team starts escalating, the InfoSec team is involved and pulled in, and then that's when we call off the red team exercise. It was clear the red team was very effective here, and that's why we had this whole process. But it was good to find the holes here. I will note that that was a very, very contrived attack example. Maybe not many of you in the room go in and have or engage with red teams to target very specific setups and scenarios to basically prove a point. In this case, it required that the hired red team had to be briefed on where and what to look, and it required that the red team be given some initial kind of cookie or like initial access or initial into the system. Hilariously enough, this ties really well into Filippo's talk because the way that they did so was through custom modifications of a application dependency. So we know what happened there. And so that was from the previous talk. So complex red team. But could there be a simpler scenario like of this that could happen in real life? So let's talk about an example with Target and the HVAC company. For those of you who remember in 2014, there were some hackers who basically were able to scrape a bunch of payment data from Target through an in via the HVAC company that Target was contracted with. They first broke in using network credentials that were stolen from the HVAC contractor. The question everyone asked was, why did Target give the HVAC company access to the payments network? That seems like two systems you should not put together. The answer is that the vendor needed to be able to remote log into the system to do things like maintenance. After the systems were compromised, the attacker proceeded to then upload their malicious software because they now had an into the network. The software started collecting all of the cards, all of the credit cards. And then more interesting is how the data then got off those systems. Some early reporting suggested that they were pulled off via FTP to some locations in Russia. But actually, they found that they were transmitted to other already hacked systems that presumably the hacker had already popped elsewhere in the world. An example they had was a business in Miami or a server in Brazil. Okay, so here we have some pretty convincing arguments that working with these external integrations, there's a bunch of potential problems, there's a bunch of potential dangers. So you might be asking yourself, why do we even bother to try and work with these? What is even the point of this talk? The example I have is pretty near and dear to my heart because I work at this company. I work for Square. If you didn't know what Square is a payments company. It turns out when you need payments to go and payments to flow, you need to engage in communications with major card brands. In our example, Visa and MasterCard. All of you probably have a Visa or MasterCard credit card in your wallet. It is not going to work on a Square point of sale system if we do not work with Visa and MasterCard. And so that would, if we broke off those connections, it would totally defeat the purpose of us being a payments facilitator. So, okay, we have to use vendors. But you may be saying, don't we already have security and legal processes in place? Why aren't these working? How do these processes fail? So I'm going to walk you through a little bit behind the scenes of what it would look like in most companies to establish a vendor relationship. Some of these may be familiar to you in the audience. Some of them may not be. So let's pretend here we have a company and a third party. Here's some business unit somewhere that wants to make use of a vendor, that vendor over there. There's usually some kind of centralized procurement department which handles all incoming vendoring requests. You can think of this department as a project or process or some kind of project process management team. They manage and maintain requests from all of the various business units, and they ensure that these requests make sense and are properly vetted by the different departments. One really clear example of why they're needed here is that if you have two business units wanting to use the same vendor, the procurement department may be able to negotiate a deal. You have like bulk discounts or volume discounts, making sure the contract is centralized, and then holding each business unit accountable for the costs. For the process to move forward, the procurement team usually has to check with both a legal and InfoSec department. Life in the InfoSec box is as follows. We ask for documents, we ask for questionnaires, we maybe receive half of them. We read like several hundred SOC 2 Type 2 page reports. And then based on that, we try and make a risk assessment and provide risk guidance as to whether or not it's safe to move forward with the vendor. Any guidance goes back to inform legal to augment the contract. How does augmenting the contract look like? The common one is using a data processing agreement so that you can help mitigate risk if there's potential data exposure. Once that's done, procurement talks to finance or accounts payable to actually pay the vendor with the legal agreement attached, and then that's all done. Welcome to the boring world of vendoring. Okay, now the business unit can engage with the engineering team. Are we done? Maybe. Well, despite all the behind-the-scenes process, we still need to actually tie the engineering team to talk to that vendor. And in fact, by the time it hits engineering teams, it looks like this. And the engineering team has no idea what has happened behind the scenes, unaware of all of those existing discussions, unaware of the 3 months of paperwork pushing and emails. So from their point of view, they're like, cool, I make a link, I'm done. But you might be asking yourselves, well, does the engineering team know what data is or is not allowed to be sent? Where is the security oversight? This is why a lot of companies loop in a security team to perform some kind of design review or an architecture review involving the integration with the third party. But it's also important to remember that the actual communication stream is still managed by the engineering team themselves. And especially when you have a service talking to multiple third parties, the security org may not be able to see this nice diagram. They may not be able to see what the other tangent risks are unless the engineering team happens to bring those up to the security org. So after all that, I've blabbered on for a bit. Problem number one, we come to our first technical concern, which is how do we ensure that we don't have unfettered outbound access? A solution many of you may be familiar with is implementing a whitelist system to control outbound access. The common way of doing this is via a proxy or firewall, and then engineers can submit change list requests to update what is whitelisted, and then anything that's not allowed is denied access. But then when it comes down to periodically auditing these, or even reviewing them as they come in, the domains and the IP addresses sometimes make it really difficult to understand what external third party it's actually referring to. So of the 4 names on this list, you probably only recognize 2 of them. And me, as an insider at the company called Square, I also only understand 2 of them. It's what is the vpc-example-es-pros/Amazon AWS.com? I have no idea. It's probably an AWS. I could figure out that much. Is it something hosted by us? Is it something hosted by someone else? Who knows? The other big problem is that it's actually hard to reason about which services within the company are actually allowed to access specific vendor endpoints. You may have a manually generated service map that looks like this, but in the whitelist, this is all you see, right? It's I have a list of things, they are whitelisted, and I hope everything is fine. So we come to technical problem number 2, which is we have lack of vendor integration context. So when it comes down to performing reviews or audits, even if you have a good every 3-month cycle of reviewing what's on this enormous list, you still have very little to no context for the integration. So what we did was we decided we were going to be a bit more proactive about this and see what we could do to improve the situation. So let's look at the original problem. The first step here is that we want to tie vendors to apps somehow. We have our service map that looks like this. Let's simplify a little bit to see what that technically looks like. Simplify it more, and so at its very simple form, base form, we have a relationship between the application and the domain it needs access to. That's really great, but it doesn't solve the problem of knowing what the domain is associated with in terms of what vendor is it attached to. So let's see if we can extend these models a bit better. Instead of having the app tied to the domain directly, we actually want them to be tied to the vendor. And actually, if we consider the vendor to be a company could have multiple different products, each with their own sets of domains. So one example might be Google has PubSub, which is separate from, I think they have Stackdriver, and those are totally different use cases, totally different domains. You don't want to kind of mix those together. It would be super nice to capture as to why different apps need access to these different products. So we somehow need to attach some data to that kind of product and app relationship. So we can create an integration model here, and what does that integration model contain? It can be tied into things like design docs or ticket IDs or whatever fun review process system you have. We'd also like to use this as an opportunity to add relationships to particular DRIs, so either an original user or a group or team or role that is responsible. Okay, so we have this nice model. diagrammed out. What does that look like in practice? So this is a screenshot from a dev environment of me generating this, but this is something we have been working on over the past year and a bit. And instead of having that laundry list of domains that I showed earlier, we now have a lot more contextual information. This is the view from kind of the application. You can see the contextual information on the vendors and the products that are used. It can contain a thing like a short blurb as to why we have the integration, what is the description of the data being transferred, what are the domains tied to it, and what the approval state of each integration is. And you might be saying to yourself, did I just hear her say, the review state or the state of approval? And you are right. That's because any new integrations that go through the system need to go through review as part of vendor security before they're approved. And before the whitelist is enabled for them. So when adding a domain, the first thing to ask is it part of an existing vendor? Is it a new vendor? If it's part of an existing vendor, then you need to make a request to change the domain or IP list. And that way, InfoSec can jump in and say, okay, this actually belongs to this vendor. Maybe you actually want to do a new vendor and you want to start a new vendor relationship. That's a lot of words. Okay. So if you go back then to Bob, and thinking about him making that change to allow node C. Bob here got auto-denied initially. We now have an automatic technical security check, so if he wants to enable it, someone from vendor security comes by and says, hey, why are you making this change? It would be nice if you could provide some more information. Could you please document your change, put it in this nice little form, and then everyone will be happy. And so Bob is able to do that. And with the supplementary documentation, the vendor security person runs away and says, yay, everything is fine. Get to approval. Or, nay, we need to do more investigation. And then so instead of this whole attack, as I showed before, we now dump that whole top piece, and hopefully engineering investigates sooner, and then we can identify the red team sooner. So is this it? Have we solved everything? Is this magical UI system really the solution to all of our vendor security woes? I think there's still a lot of future work to be done in this space. That is still very, very simplistic in terms of all we need to do is manage assets. And in fact, a bunch of this future work is one of the reasons why I'm still on privacy engineering and I still have a job. Some things to think about. It'd be nice if we could do some deep analysis of egress of things exiting our system. It'd be nice to do some schema analysis or tagging data types in the data exiting the system. It'd be nice to throw an alert if there's not a change in how much data is going out, but a change in certain types of data going out. And there's probably a myriad more problems that I haven't thought of that I'm happy to talk more with the audience after this. These are going to be the kinds of things we're thinking about throughout this year and into next year. And with that, thank you for listening. I'm happy to take questions at this time.